So thank you for the opportunity to talk today. I think some of you already heard me talking last week in Amsterdam. And I'm going to talk today for Alfamation about display functional testing. So when it comes to making sure that the products, the end product, or even some components meet the requirements once they are produced on the production line. So just a quick word about myself. I am in optics for more than 12 years, and 10 of which for Alfamation, where we build automated test equipments. So just about Alfamations, since March this year, we are part of the InTest group. It's a US-based company with the headquarters in New Jersey. And there are three different divisions. Electronic test division, where Alfamation is sitting. Then we also have environmental division with thermal solutions, and also the process division, providing also a solution for semiconductor process technologies. Alfamation, the headquarters is in Italy, in the northern part of Italy, and we have about 130 employees. The strong characteristic of Alfamation is the very strong engineering team and the capability to adapt to the innovation of the different industries where we work, like consumer electronics, automotive systems, including displays, infotainment systems, and also micro-optics and photonics. A quick overview of the systems that we build with different shapes, different sizes. Some of them for electronic testing. We also make some modules, individual modules that we sell as a standalone instrument. We use them also inside our equipments, and we have some functions like video generation, communication protocol, and we use them to communicate with the displays, for example, sending signals, video signals or commands for the display. We do have also a wafer level test platform, which I talked about last week, but today I'm going to focus on the pixel shooter platform, which is the one you see here that we use to test display. And as I said before, the challenge that we have is to ensure the quality of the display in the production line. And to do this, we verify different functions of the display, like electrical and firmware functions. So basically verifying the voltage, currents, consumption, and so on. We also have inside the system optical verifications, like defective pixel, color measurements, brightness, contrast, uniformity, flicker, and so on. And when the display has also a touch function, for example, we also have haptic testing solutions with fingers, robotized finger, for example, or vibration sensing to make sure that also the haptic feedbacks are working. All of this we do in one single test station. So this test station that you see here can be fitting all the tests that I described just now. And I'm going now to go in more details on what kind of implementation we do and how we do this inside. So a typical system is made by a vision camera, high resolution, about 50 megapixel, sometimes 30 megapixel, depends on the resolution of the display, which is to test. We have a SCARA robot, which has here the possibility to load different end effectors, different tools like fingers for touch, colorimeter to test flicker and colors, and also we have fingers with multiple fingers to test multi-touch functions with 5 points or even more. And we have different kind of interfaces with the line, with the operator. It can be manually loaded or also interfaced with an external robot, loading automatically the device under test inside the bay. And this tester that you see here has a rotating table. And this rotating table has the advantage of having two devices loaded at a time. One on the outside, which can be loaded and unloaded. And we can already start to boot it up and do some tests, electrical test. And the second one is inside the tester, doing optical tests and touch tests with the robot. Once finished, the table rotates, and you can, in this way, optimize the cycle time. And this is an example of a real-life test cycle that we did on a display. And with all these steps that you see here, including electrical test, some firmware programmation, touch test, color test, ambient light sensor test, and so on in 58 seconds. And you see here in gray on the bottom is the same test going on the second display on the rotating table. So you can see the benefit in terms of parallelization of the process and the gain in time. This is a quick overview of the setup we use to calibrate the ambient light sensor on the display, if it has it. We do use a white LED light source with a collimator to shine directly on the light sensor on the display. And this illumination is calibrated with a lux meter to make sure that we calibrate the sensor to the lux reading from the calibration. This is an example of pixel defects detection. This is a simulation of a display of a defect by putting an image simulating a black pixel, and with an in-house algorithm, we can detect down to the sub-pixel defect. We also developed some uniformity and Mura algorithm looking at some bright and dark areas on the display. And we use the standard which are defined by the German automotive standard in terms of algorithm to find the defects and being able to put the limits according to the standard. And this is an example of the Mura test with the gradient image. So the Mura test is basically looking at gradient variation into the display, and typically with this test you can see if there is stress on the display, which is put and giving some bright areas. So just to finish, and this is the usual question, that what we are looking for is to keep pace with the evolution of the technology. Right now, I talked about displays about 10, 12 inches for automotive, typically, like instrument cluster, infotainment system displays. And we are looking at also testing different kind of displays like micro LED, OLEDs, also head-up displays, and potentially also holographic displays. It's for sure quite a challenge because maybe most likely the way of looking at display is different than what we do today. And this is what you can do for us, maybe having a test case that we can work together on to automate it, or if you have an instrument that does a test but needs to be integrated in a platform, we can also do it. As I said, we have a very innovative mindset in Alfamation. It's been 33 years of innovation so far, and with a very strong engineering. And we do have proven platforms that we developed over the year that gives quite some comfort in this development because we have a good base to work on. So that was it for me. Do not hesitate to get in touch later or ask questions right now. Thank you very much for your attention.